At NOAA's National Severe Storms Laboratory, it's our mission to be the world leader in observing, understanding, and modeling severe thunderstorms. In order to accomplish our mission, we can't do that only in the laboratory. We have to get out into the field.
So whether it's tornadoes, lightning, hail, wind, flash floods, you really have to have ground truth and the observations from the phenomena to be able to figure out what's going on and how to better forecast and warn for it.
Everything we do is synergistic, so what we see in the field kind of provides new insights to the people who run the computer models to show us how storms work. Both of those things kind of provide new insights to the forecasters, so when they're looking at radar, they know of new things to look for to guide their tornado warning decisions. So all these things kind of feed on each other and grow together. Back in the early days, it was just people driving in cars with paper maps and making notes and taking pictures on slide film. So, of course, everything we do has kind of evolved with technology, where you add the mobile communications part and the ability to communicate digitally between teams so we can all see what each other are doing and that everyone's in the right spot for the data they need to collect. But more importantly, we can watch each other's back. One of the big things I think the evolution has allowed us is to be able to send multiple vehicles with multiple different tasks and missions all over a storm. And all of us kind of have a common idea of what we need to be doing and can communicate with each other about what we're doing out there. It's been a long tradition and practice here at NSSL that when we go to the field and gather observations and see what we're missing, we'll actually invent the instruments and the approaches that we need to go out and gather that data in subsequent years.
We can try new equipment, we can try new data collection strategies. We can try to create entirely new instruments that don't currently exist. And by doing so, we push that boundary forward and we're continually opening up new avenues and new questions that we can ask.
It's a big effort to pull something like a field project together, and we gain a lot of invaluable data, which can serve as research projects for future students and, be able to get us some of the questions that we don't have the answers to.
Every field project that we do, we spend months, if not years, of effort planning, budgeting, designing, building all of the equipment that we need, figuring out how many people we need to actually operate it. That's staff and students and getting everybody hired. I mean, there's all of these logistics.
Sometimes we go out with dozens or close to 100 people in a number of vehicles. So just getting all those people ready to go, getting them to the field and getting them in the right spots to collect the data they need to do is one of the big challenges we face nowadays.
We're dealing with severe thunderstorms, which are inherently hazardous. We also have safety concerns with things like driving on wet roads and windy conditions. So we spend a lot of time making sure we account for safety as we prepare for a field campaign. It takes a lot of people working together in long hours and stressful environments and situations. So the more collaborative that you can be going out in the field, the greater the chance of success by being able to keep communication open.
When we combine our assets and we combine our knowledge and work together as a team, that's how we achieve larger goals than we can by ourselves. So when we do projects like this, when we do research objectives, like we're constantly partnering with other people. Hey, we're gonna bring this instrument to the table. What can you bring to the table? Everybody has different strengths and things that they can provide to that larger team environment.
One of the things that I think is really fascinating about the fieldwork that we do is that we're studying all these different aspects, and different groups might be collecting different observations on the same storms. But all of the processes are actually really intertwined. So a lot of the same things that are happening in a thunderstorm that create hail are also the things that are happening in a thunderstorm that create lightning. And how those things happen also changes how your storm evolves and whether or not it might later produce a tornado or something like that. So all of these things all tie together, and we're all trying to get at the bigger question of what the entire storm is doing.
NSSL has been studying severe storms for well over 60 years. The scientific discoveries, the scientific advancements that we've been able to make have made a significant impact in terms of our abilities to provide better warnings and support the National Weather Service forecasters in terms of their mission of protecting lives and property. That really is our passion. And that's why we do what we do.